Okay, so the feature that we're standing on here at stop number 1 is a drumlin. We actually have 2 features that we're going to look at here. We'll talk about this one first, and then we'll move on to feature number 2. So as you were walking up the hill to get to this location, what did you notice about the particles that you saw in the road cut? Were they angular or were they rounded? They were angular. How about the grain size distribution? Did there appear to be a broad range in grain sizes, or was it a very narrow range of sizes?
Wide range.
It was a pretty wide range. This is composed of angular glacial material that ranges in size from clay-sized particles all the way through to boulders. Does anybody remember what the term is for material that has been deposited by the glacier?
An esker?
Till?
A very general term.
Till?
Till. So this is composed of till. Now if we consider the range of grain sizes, the fact that it ranges from clay through to boulder-sized particles, would you describe that as being well graded or poorly graded, do you think?
Well graded.
Well graded. So grading is an engineering term, and engineers like material that has got a range of grain sizes so that it packs together and they can use it for all sorts of different purposes. So if something is well graded, then what you have is a gradation of grain sizes from small through to large, and you have a fairly even representation of all of those different sizes. Geologists refer to particle size distribution in terms of sorting. So is this well sorted or poorly sorted material?
Poorly sorted.
It's poorly sorted material. So a whole bunch of different grain sizes that are all jumbled up together. There's no real sorting. So if you have a look at the first part of your handout here, internal makeup and origin, what you should have in there is well graded, poorly sorted till. Make a note that the material is angular, because we're actually going to look at some outcrops where the material is not angular. We're going to look at some rounded material. Does anybody remember from your lectures last week how these drumlins form? What's that? Yes, they are formed by glaciers. They are formed by some fairly specific actions. Are they formed during glacial advance or glacial retreat? They're formed during advance. So, drumlins are pretty interesting. They're actually formed when glaciers advance over the top of till that has been previously deposited. Now the base of a glacier is not flat. It has ridges and undulations in it, and as it moves over the top of the pre-existing till, it kind of squishes it up into those cavities at the base of the glacier, and it creates something called fluted terrain. So what we end up with is a series of these sort of elongated hills that are aligned with each other, and they show us the direction of ice movement. So it's not particularly easy to see while we're standing here, but there are two ends to a drumlin. There is something called the stoss end, and then there is the lee end. One of them is steep, and one of them is very gently dipping. Do you remember which one is which?
Stoss is steep.
The stoss is steep. They sound alike, pretty easy to remember it that way. So on this particular drumlin, the stoss is behind me. That is the stoss end of the drumlin. The lee is in that direction there, and we'll be able to see that when we go around the corner on the bus, and you can look out the window and you can see that gently sloping drumlin. So which end shows you the direction of ice advance? Which way is this drumlin, which way was the ice moving when this drumlin was formed?
Towards the lee end.
Towards the lee end. So it was coming from there, and it was moving in a southwesterly direction. So if you have a look at a map of this area, or have a look on Google Earth, what you'll actually see distributed between Lindsay and Peterborough is this whole region filled with drumlins that are aligned in that orientation, and there are about 3,000 of them. something in the vicinity of 3,000 to 5,000, depending on which geomorphologist you talk to. Topographically, they're about 25 meters high and can be up to 400 meters long. So a reasonable size geomorphological feature, if you like. Now, if we think about how this thing formed, there was glacial till. It's material that ranges in size from clay-sized particles all the way through to boulders. And it was mowed over the top of by 2 to 3 kilometers of ice. So what do you think happened to that till when it was being run over by the ice sheet? Do you think that it is now compressed and consolidated, or do you think the material in here is still quite loose and friable?
Compacted.
It's pretty compacted. Yeah, these things are quite dense. So that has some implications for drainage, and it has some implications for things like land use and the kind of vegetation that's going to grow on the top of it. So we can think about drainage on a drumlin in two ways. We can think about the surface drainage, so the water that's potentially going to flow over the top, and we can think about the internal drainage. So what do you think the internal drainage is going to be like? It's full of clay, it's dense, it's compacted.
Poor.
It's going to be pretty poor. Yeah, there's not much opportunity for water to percolate through a drumlin. How about the surface drainage? What do you think?
Yeah, because if there's nothing percolating internally, then it's all just going to run off the surface, right?
Yep, it's going to be pretty rapid. There's going to be very good surface drainage. So water that hits this, a little bit is going to seep into the surface, but most of it is going to run off the side. Now, one of the characteristics of clay, clay minerals, and clay-sized particles, is that they do a pretty good job of holding onto water. So once something gets saturated, then it's going to stick around for a while. And that has some implications for the kinds of vegetation that we see up here. Now, if we look at this particular drumlin here, you notice that there's some grasses, there's some apple trees, there's a bit of sumac around here. But this is actually been cleared for pasture land. This is not the native vegetation. If we have a look at some of the high points that are around us, what kind of vegetation do you see there? What kinds of trees? Deciduous trees, hardwood trees. That's because there's enough water that's retained on this to actually facilitate soil development and nourish those trees. They actually need quite a bit of water. They need fairly good soil. So that soil is formed by the breakdown of the mostly limestone fragments in this particular drumlin field that forms these drumlins, and the fact that that it holds on to enough water that it can facilitate the growth of those hardwood trees. So in your comments section here, I want you to make sure that all of these things are filled in. And in the comments, I want you to make sure that you've got things written in there like drift. So all glacial deposits, it's a general term for everything that's deposited by a glacier. It's formed by till, so that's the material that's been dropped by the ice. It's angular material. And is this an ice contact or a water contact feature?
Ice contact.
Ice contact feature.